Good day. You've just watched a PowerPoint that outlined the steps for balancing redox reactions. And so it reminded you that you need to balance a half reaction for reduction, balance the half reaction for oxidation. Look at the electrons in both and find the lowest common multiple. Probably sounds like mumbo jumbo, so best to start some examples. This video will do example 1. When we look at this, we see there's chlorine here, chlorine there. We're going to put those in one half reaction and balance. And we're going to take the I minus here and the HIO and make our second half reaction. One of these will be reduction, one has to be oxidation. So there we are, we've taken the chlorine, two different oxidation states. We know this is 0 and we could calculate what the chlorine is. So we have to balance out the chlorines, 2 chlorines there, so we have to put 2 there to balance the chlorines. That's the major. Now we balance the oxygens by adding water, and we balance the hydrogens by adding H pluses, and we'll balance the charge. So when we look at this, we had the 8 hydrogens on the right, we had 2, that's why it's 6 H pluses here and 6 electrons, and you may want to put a star by this because this is going to be our reduction half reaction. We're going to do the same thing for the iodide. So now we look at this and we say, okay, the iodines are balanced, so let's balance out the oxygens, and we do that, and then we balance out the hydrogens, and let's see what we get there, boom. And to finish off, we have to balance out the charge, and this was -1 on this side, this was +1, that's why we had to add 2 electrons to bring it down to -1, like it is on the left. Again, put a star by it. Here's our reduction half reaction, here's our oxidation half reaction. Now what we really care about is 6 electrons there, 2 electrons there. And we need that 6 and the 2 to be equal. So no problem, we can see 2 fits into 6 3 times. So we're going to have to multiply this half reaction by 3. So we kept this original redox. I just brought this down from here. There's our reduction half reaction. And now I'm multiplying through by 3. That'll balance out the electrons. The number of electrons lost will equal the number of electrons gained. And now everything gets multiplied by 3 in that half reaction. And so expanding out, boom, boom, everything's 3 except for the 6 electrons. So our 6 electrons are now balanced. Once you've got those done, you really have the question beat. You've done all the hard work. So what we're going to do is we're going to take all these reactants here and all these reactants here, and we're going to put them as our total reactants. We're going to take all these products from this half reaction, all these products from that half reaction, and they become products in our redox reaction. Now, I'm not going to write in the 6 electrons because they're designed to cancel out. So that's what our redox reaction now looks like. But we can see that we have to simplify it. We got 6 H pluses there and 3 H pluses there. So we get rid of them on the right, and 6 minus 3 leaves 3 H pluses there. We have 3 Wawas here, 4 Wawas here, and so we're going to have no waters on the left and just 1 water on the right. So that is our final redox reaction, but we should always double check. So we go element by element. 2 H's there and 3 H's makes 5. 3 H's there and 2 makes 5. 2 chlorines, 2 chlorines. 4 oxygens there, 3 oxygens and 1 is 4 oxygens. And we have 3 I's there and 3 I's there. Now, 3 plus 3 minus, this side equals 0, and no charge on the right. So it's balanced in terms of atoms and charge. So that is our first example, all done. We're going to move to example 2.